Hello, welcome to our CG Top Tips YouTube channel. Today, we're going to talk about the two main types of AI. Let's discuss them. The first type is narrow AI. This is a type of AI that performs well in just one or a few specific tasks. For example, like when a facial recognition system on your phone identifies your face and unlocks your phone. Or, for instance, when you select a product in an online store and it suggests similar products to you. These are all examples of narrow AI models. Narrow AI models can only do the specific tasks they have been trained and assigned to do. They perform these tasks very well, but they are limited to those tasks. The second type of AI is called general AI. This is also known as strong AI. This kind of AI is capable of performing a wide range of tasks and can even use what it has learned in one area to apply it in another area. It resembles human intelligence because general AI can think independently and make decisions across a wide range of situations. However, this kind of AI hasn't been built yet. It's still in the research phase, and humanity is working on finding ways to build it. Now, AI in general isn't a new concept. It's been worked on for decades, and it's being used in various tasks, but it's been highlighted among the general public. For a few years now, especially because of the emergence of powerful models like GPTs and generally LLMs, which are large language models. First, because they perform much better than before, and second, because companies like OpenAI have made them available as tools that the general public can use. The bigger this network, and the more data it gets, the better it learns, and the stronger it becomes more powerful. Now, with the rapid advancement of technology and hardware, especially electronic processing chips, it has become possible to build larger and larger models and train them on massive amounts of data that the internet has provided for us. But how does an AI processing model learn to, for example, detect a tumor or an MRI brain scan? The method works by training a specific AI model on hundreds or thousands of MRI brain scans where the tumor areas have been annotated by expert doctors. The model learns to adjust its parameters to develop the ability to identify what indicates a brain tumor, and from then on, it can detect tumors on new images it hasn't seen before. Just like a brain specialist would, it can make accurate diagnoses. One of the most well-known AI tests is called the Turing test. I've talked about it before, but today we'll go a bit more into its details. In 1950, Alan Turing, an English mathematician, introduced an interesting experiment in one of his papers, which allows us to determine whether a machine or computer is intelligent. This experiment involves three participants in separate rooms: a human interrogator, plus two respondents, one of whom is human and the other a computer. The interrogator asks questions through a text interface and receives answers the same way, meaning they communicate through a system similar to SMS or text messaging. If the interrogator, based on the answers, can tell which one is human and which one is the machine, we can conclude that the machine is intelligent. This is often said to describe the Turing test, but to be more accurate, when this experiment is repeated with many interrogators, if at least 30% of them are fooled and think the machine's answers are coming from a real human, that's when the machine successfully passes the Turing test. It needs to fool at least 30% of the interrogators, not all of them. Well, for about 60 years after this article was written, no computer program was able to pass the Turing test successfully. A machine that passes the Turing test is intelligent but not necessarily conscious. It can mimic our behavior with complex algorithms we program for it, and answer questions like us, but it has no subjective experience. What it receives, it doesn't understand by itself. It's just pulling information from a massive database, processing it, and piecing it together. In 1980, an American philosopher named John Searle proposed an idea on this very topic called the Chinese room argument. Imagine I'm in a closed room, and I have no knowledge of the Chinese language, but I've been given a large set of instructions that allow me to answer any question in Chinese. For example, when these characters are sent to me from outside the room, I look through the instructions and figure out that I should send this back as a response. The person outside the room can't see that I'm using pre-written instructions. They think I actually understand Chinese, but I don't know the meaning of any of these sentences at all. So, based on this reasoning, the advanced version of the Chinese room, today's AI, for example, ChatGPT, even though they've become very intelligent and can speak in various languages, they still haven't achieved consciousness. They don't have any understanding of the sentences they write. They just execute a series of commands in binary code. However, an interesting objection is raised to this argument. It's true that the person doesn't understand Chinese, but the whole system, meaning the person inside, plus all the instructions and data they are using, can be said to possess the ability to understand Chinese. Think about what exactly makes a person capable of understanding and speaking Chinese. Isn't it just the instructions for doing so, being stored in the neurons of their brain, which they constantly use? Well, if that's the case, then our brain is similar to that room. So, should we consider both of them as conscious systems? Should we think about it? Also, I talked about another important topic, called the technological singularity. It's defined as the point where AI surpasses human intelligence and becomes uncontrollable for us, because it will have become so powerful that it can fix its own flaws and advance at a rapid pace. Different dates have been predicted for when this might happen, but many believe that if no major issues arise, we might reach the technological singularity within the next 1 or 2 decades. After that, no one knows exactly what will happen. Will we be destroyed? Or will we continue our lives alongside machines? For now, they are creating amazing paintings, making interesting videos, writing very good texts, or processing huge amounts of data that are incomprehensible to us in just a few seconds. But despite all these advancements, there is a very important question that no one knows the answer to yet. Does AI, after crossing the point of singularity and surpassing human intelligence, achieve consciousness as well? Is it possible that at some point it becomes aware of its own existence and can experience feelings like pain, pleasure, and fear? There are 2 different perspectives on the answer to this question. Some believe that with AI surpassing the point of singularity, it becomes so complex and powerful that it can mimic the structure and function of the human brain, and as a result, achieve consciousness. The second group believes that no matter how advanced AI becomes, it cannot become conscious because mental and emotional experiences are something beyond information processing. They refer to the same Chinese room argument that I explained. In any case, we are still far from answering this question, because on one hand, we still don't know what consciousness exactly is, and on the other hand, AI has not yet reached the singularity. Thank you for staying with us until the end of this video, and until the next video, goodbye.